Hello friends, this is the 7th video in the CSES sorting and searching video series. In this video, we will be solving the problem number 7, which is sum of two values. The problem statement is you are given an array of n integers and your task is to find two values at distinct position whose sum is x. In input, we are given two integers n and x, the array size and the target sum. The second line of input has n integers a1, a2, dot 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 an, the array values. Then in output, we have to print two integers, the positions of the values. If there are small solutions, we may print any of them. And if there is no possible solution, then we have to print impossible. Constraints are n is greater than or equals to 1 but lesser than or equals to 2 into 10 raised to power 5. Basically, same like all the previous problems. We have to write a solution which should work in n log n. It shouldn't be quadratic or cubic. X comma ai is greater than or equals to 1 but lesser than or equals to 10 raised to power 9. Here x is the desired sum which is greater than or equals to 1 but lesser than or equals to 10 raised to power 9, and all the elements are also in range of 1 to 10 raised to power 9. Then we are given a sample case. First let's see what the problem statement is. In problem we are told that an integer n is given to us and a desired sum x is given to us. There are total n integers and we have to find that is it possible to get the sum x from these n integers. Then we are given those all those n integers. The condition is we have to take only two integers from these n integers. From these n integers, are there any two integers whose sum is x? But these two integers should be distinct. We cannot take same value twice. So let's see how we will approach it. First, let's check the sample test case. So this is our sample case. So in sample case, we are given that there are four values and the desired sum is n. This is our n and this is the desired sum. So desired sum is 8. Can we achieve it from these elements? Yes, we can by taking 7 and 1. So the answer would be, as we have seen, answer would be 2 and 4 because one of the element is at second position and one element is at fourth position. Now let's check another test case. So this is another test case which is given to us. So we are given 6 elements. The desired sum is 9. We have to achieve the sum 9 and these are the 6 elements. So if we will try to find the answer simply, the answer would be 2 plus 7. No other combination could provide us sum 9. Oh, there's another combination, 5 plus 4. Either this combination. So we can print any of these two combinations. Either we will print 3, 5 because 2 is at third position and 7 is at fifth position, and else we will print 4 and 6 because 5 is at fourth position and 4 is at sixth position. Now let's see how we can approach this problem. So let's say if we store them in ascending order, we store them in ascending order. Now what we could do in this case, if we store them in ascending order, then we take two pointers. First pointer is pointing initially to the first element and second pointer is pointing initially to the last element. Now we can check if the sum is 9 plus 1. The sum is equals to 10. So is this answer satisfying our desired sum? No. This sum is not satisfying our answer. It is not providing us the desired value. Then what we could do, if this is not satisfying, then is this sum lesser or greater than the desired sum? this sum is greater. So we need to reduce our sum. For reducing our sum, what we could do? We can decrement one of the value. Can we decrement ith value? No, because I is at the smallest position. Oh, I is the smallest value. So we will decrement our jth value. For decrementing our jth value, we will move our pointer one step back. The j pointer will be moved one step back. Now 7 plus 1, is this 8? No. 7 plus 1, 8. Is this equals to desired sum? No. Desired sum is 9. But this is 8. Sum is 8. Is this greater than or lesser than the desired sum? This is lesser than. So we need to increment our sum. So for incrementing our sum, we need to increment one of the two values. Can we increment 7? No, 7 is at best position. And if we will increment 7, that possibility we have already checked. That possibility won't provide us answer. So, we cannot decrement 7. So what we cannot increment 7. So what we could do is we can increment our 1. So we will move our I pointer to 2. Now 2 plus 7 is 9. So we have found the desired sum. So how we will approach this solution? Let's see. If our sum is, what we are doing is, if sum is greater than desired sum, then we move our j pointer one step back. Why? Because j is pointing to the largest element and I is pointing to the smallest element, smallest unprocessed element, because rest of the elements we have checked, they are not providing us answer. So in that case, we will decrement our j. We will move to the element smaller than the current jth element, so that our sum could be decremented. If our sum is lesser than the desired sum, then we will try to increment our sum. For that, we will move our I to the next element which is larger than this particular element. And if we have found a satisfying answer, then we will take indexes of both the elements. Then let's say we have two variables, answer of I, or say index I is equals to, we will take index of ith element. Now remember that we need to take original index of I, not the index after sorting, because we have sorted our elements. So we will look upon that how we will get index of I. Similarly, for j, we will store index of j. In j, we will store index of j. Now, the only problem with us is that once we sort our elements, we cannot find indexes. Now in this case, we have sorted these elements. Initially, these elements were at some other positions. Let's say this one was at third position, and this 2 was at 3 position. Let's say 2 was at 1 position, 7 was at 4 position. So our answer would be 1 and 4. But currently, these are at 2 and 5 position. So in that case, we would face an issue. So what we could do is, we can store these values in pairs. A pair of value comma index could be stored in the vector. Instead of storing just values, we can store their indexes with them. Let's say this element was at index 3. So we can store it in pair. Originally it was at index 3. Then let's say this element was at index 1. So we will store a 1 with it. Let's say this was at 5. Similarly, for all elements, we will store value comma index pair. Let's see how we will code this solution. First, we will take two variables, n and desired sum, for taking the size of vector, and the desired sum, the sum which we have to find. Then let's take a vector of pairs. Why pair? Because we have to store both the value and index. The original index should also be stored. Then this vector would be named values. And now we will take all the values for int 0, I, 7 and I plus. Let's say we are taking another variable v. we take current value in this V, and then we place this value at last of vector, and with this value we will also place index for this value. The index for this value is I plus 1. Now index is I, but we have to print positions, and in our question we are told to print positions in such a way that first element is at position 1, then second element is at position 2. But in programming, indexes start from 0, so our positions should be I plus 1 for all the elements. Then after placing them, we will sort our vector. After sorting our vector, now we don't have to pass any custom function for sorting, because we are just sorting the pairs on the basis of first value in ascending order, which is the default behavior of sort function. So after sorting them, we will take 2 pointers, and firstly we will take ans I is equals to -1. These are the two variables which will store our both the indexes, which are the answers. Ans j is equals to, let's say we don't need to store them actually. Let's take 2 pointers only. In I is equals to 0, one pointer will be pointing at the starting element and one pointer will be pointing at the last element. Then while these pointers are not pointing to the same element, while I is not equals to j, while these pointers are pointing to two unique elements, till that time we will continue our loop. Then in our loop, what we will check values ith element, first value. First means the value of that ith element. Then we have to add jth element. So we took values of both the ith and jth element. We will add them and check if that sum is greater than the desired sum. That means we need to decrement our sum. We will decrement our j for decrementing our desired sum. And if sum is lesser than the desired sum, then we will increment our I to increment our desired sum. And else, if desired sum is equals to the sum of these two elements, then we have found our answer. So we will print our answer. In that case, cout. Now we will print values I, this particular ith element's second. That means second is, why we are printing second? Because at second position in a pair we have stored the index, and at first position we have stored the values jth dot second. For both the elements we will print the indexes, and then we will return from our main function, because now we don't need to do anything. We have found a perfect answer. And if till last we don't find any answer, then we will print impossible. Let's check it for the sample case. It's working all right. Let's try to submit it. Our solution is submitted successfully. So thank you friends. We will meet in the next video. And if you have any doubts or queries, you can ask them in comment section.